Hi there, this is video U528, more Z-score practice, and it's finding percents part 2 in reference to section 5.5 in your textbook. How about you read the question, you turn off the camera, you give it a shot, and then either consult the answer key or turn the video back on and see how you did. All right, I'm going to trust that you did that. So let's take a look. Pat and Chris both took a spatial abilities test. The mean was 80 and the standard deviation was 8. Okay. Pat scored a 76 and Chris scored a 94. What percent of individuals would score between Pat and Chris? Okay, well, I read the whole question, but it's mean to say, but I stopped caring when I saw a mean and standard deviation. Because I knew I was going to have to draw my curve. And I pretty much knew that anything else I read I was going to forget by the time I finished my curve. Here's my mu, and there's my mean 80. So we got plus 8. So that's going to be 88 and 96 and 104. But you know, I'm going to be really annoyed if that's not right. All right. So 88 minus 8 is 72. Minus 8 should be 64. 56. Again, don't judge me. So 80 minus 8. Minus 8. Minus 8. All right, cool. What do we need? This is score. This is spatial abilities. Test. This is frequency. Nope, we need to put in our percents too. Whoopsies. 0.15. I haven't apologized for a while. My curves always look like that. I know that a normal distribution is supposed to go more like that. But every time I try and draw that, I never have enough room across the bottom. So I have one that's got a huge spread to it. Okay. Yeah. Pat scored 76. So, yeah. It said Z-score at the top. You knew we were going to have to do some calculations. So 76 or 72, there's 80. Let's see, 76 is right about in the middle. And Chris scored a 94. All right, so this was Pat, and this was Chris. So what we are looking for is the area in between. Estimate. I'm going to erase this sad curve over here. Well, the only thing I know for sure is it's going to include this entire area of 34. I just got part of this one, part of that one, so that's not really too much. So I better say more than 34%. It's kind of a sad little estimate, but that's okay. we'll work with it. We can double check it later to see if it's reasonable. All right, so let's look at Pat. And you knew, because it said set score up there, or the fact that his score that he got doesn't match any of our beautiful magic numbers across the bottom, we have to do a set score. All right, so he scored 76 minus mean was 80 over 8. So Z score, it's going to give me minus 4 over 8. All right, so if we remember where mu is, let's mark mu in the center here. Pretty green pen. All right. First of all, Pat was below the mean, so that negative makes sense. And yeah, that makes sense that he is 0.5 standard deviations below the mean. All right, you know what? I'm going to calculate Chris's, and then we'll pull out the table and do the final. We'll find the actual areas. So Chris Z is equal to x minus x bar over sigma. And Chris scored 94 minus mean of 80 over 8. That's going to give me, and then not 18, 14. 14 over 8. Okay, don't tell anybody I'm doing this. Again, I don't want to make mistakes in front of you. Divided by 8. 1.75 standard deviations. So let's see if that makes sense. So there's our 0 point. There's 1 standard deviation above and some more, but it doesn't quite make it all the way to 2. So yeah, that's cool. But it's not asking about standard deviations. It's asking about percents. So hold on, I need to get a fresh piece of scrap paper here. Oops, it's scrap paper. I think that was a fudgicle. Negative 0.5. Okay, remember we need 2 decimal places for standard deviations. So we can add these. Add a 0 there. And the other one was 1.75. Okay, grabbing our table. Right, you guys have got one of these. So, whoops, I got it way down the bottom here. Hopefully we can see it. All right. Negative 5 point. Yeah, be really careful. Because look, it starts out at 9. We have to go all the way over to this edge. So 30, 85. 0.308. And if we multiply, you know what? We'll do that on the other page. Now I need 1.75, and that's positive, so I need the next page. So 1.7, and then we go over until we hit the 5. So 1.7, this row, and this column. Right. So the area onto the graph for this one is 0.385. Which is 30.85%. And over here, 95.99. Whoopsies. All right, never mind. Go make it look the same. So I start with A, the number from my table, 0.9599. Okay, so now a lot of things will get to this point and then go, now what? We want a percent. So we knew, okay, here's what I did. I saw mean and standard deviations. I knew I had to draw the graph. And then when I saw these two scores that weren't my bottom numbers here, my nice little magic numbers, I knew I had to do z-scores. And it asked for percent, so I knew I had to consult the data. So even without fully understanding 100% of what I have to do, I can get to this part. Now, what do I do with those numbers? There's 2%. I only need one. There's a lot of options here. What happens? Just thinking you're going, I don't know what to do. If we add those together, you get over 100%. So that doesn't make any sense. If you subtract them, you trust me, it's over 100, right? Right? 95 plus 30, I don't know, it's like, what? So 95.99 minus 30.85. Okay, so, sorry. And the truth is, if you multiply these numbers together, multiply them, I'm just going to, right, you get in thousands. If you divide them, it just gets weird. So subtraction is the most reasonable answer, which is a terrible way to do it. But I want to show you what this actually means. So I'm going to redraw our picture here. I'm going to make it a little easier to see. So here is Pat's score. And Pat's basically scored better so this area here is 30.85% of the data. So he scored better than 30.85% of people taking this test. Now Chris scored somewhere over here. Okay, now his number of that represents this delightful area in green. .99%. Well, how do you find out what's between? Well, you take all of Chris's, which is the 95.99, so all of the stuff I shaded in green, and I take away this little tail, and which is what they have in common, then I get 65.14. And there you go. So generally with these questions, if you're looking between two data points, just calculate them both and subtract, and you will get the area in between. Thank you.